Most engineering students fail not because they're not smart enough, but because no one ever taught them how to learn like an engineer. And you know that one student in your engineering class who always finishes the test early? The one who casually mentions that they did the assignment in an hour while you're still trying to figure out what the question even meant. And you've probably thought to yourself, damn, I wish I was that smart. But here's the truth. It's not about being smart, it's about doing things differently. See, top 1% engineering students aren't superhuman. They have just mastered the systems behind learning. Systems that you were never taught. And I know this for a fact because I became a top 1% student. And I'm not trying to brag here, honestly, just hear me out, okay? See, when I was doing my undergrad program, I wasn't anything special. I got pretty average grades. I graduated with a 3.5 GPA. Well, that was decent, but it was definitely not the top of my class. And for a long time, I thought this is how engineering was supposed to be. Very confusing, overwhelming, and mostly about surviving. But when I went back to do my master's program in mechanical engineering, everything changed. It's when I met some of the most brilliant students I had ever seen. Guys who weren't just working hard, but who were actually making it look effortless. So I befriended them. I watched them very closely, and over time they started sharing with me the strategies that they were using in approaching learning altogether. How they approached lectures, how they handled assignments, how they built real understandings instead of just memorizing facts. And honestly, the information that they shared with me was mind-blowing. It made me realize that I had been approaching learning completely wrong my entire life. So I decided to apply everything that they taught me. Not someday, not next semester. I applied it immediately during my master's degree. And the results were insane. I didn't just survive my master's program. I graduated with straight A+. Not A's, A+, and an overall of 4.4 GPA. Top of my cohort. And today I'm going to walk you through the exact system that changed everything for me. I call it the top 1% engineering mastery system. It's built around 4 powerful models. Number 1, mental model building. Number 2, active recall and spaced repetition. Number 3, weekly reflection cycles. And number 4, cognitive load management. Now I know these words might sound very gibberish to you, but in this video I'm going to delve into each one of these categories. And once you understand them, I promise you'll be shocked as to how much it transforms your learning. Not only your learning, but your results. And honestly, I believe your entire life. So without further ado, let's get into the video right away. So let me give you a little background. You know, for the longest time, I thought I just wasn't cut out for engineering. Like I would sit there in thermodynamics class trying to make sense as to why entropy increases or why enthalpy even exists as a concept in the first place. And I'd look over at the guy next to me who seemed to be casually breezing through the derivation and integral equations. And I'd just wonder to myself, am I just not smart enough for this field? And it wasn't just one moment either. It was a cumulative cycle. You know, at Bombay midterm, I actually studied for. I get stuck on a lab assignment, or worse, I would spend 3 hours watching lectures and realize that I couldn't recall a single thing from the last chapter. And then that little voice inside your head creeps in, right? Maybe I'm just not one of those engineering brains. Maybe I just don't have it like that. But here's where everything changed for me. There was this upper year student, someone who seemed like one of those freakishly competent people. You know, he got straight A's, he worked part-time at an engineering firm, he did design team competitions, all while looking like he slept 8 hours a night. And I remember one day asking him, like, bro, how do you even manage this stuff? Like, what are you? Are you a robot? Are you AI, bro? And he looked at me, I remember very vividly. He looked at me straight in the eye and he said, you see, Abbas, I'm not smarter than you. I just know how to learn this stuff. And it just hit me right there and then. What do you mean you know how to learn this stuff? What do you mean? Do you learn differently than me? And the reason that it shocked me was because I had spent my whole academic life trying to study harder, more hours, more notes, more lectures, more YouTube videos, more tutorials. But not once did I stop and think, what if I'm studying the wrong way entirely? What if it's not about how much I'm doing, but how I'm doing it? And that's what he said. You know, the guy said, I approach learning differently. I don't learn like you. And I didn't even think about this stuff. Like I had spent my entire life not even thinking about this stuff. I just increased the stress levels in my life by studying more, by working harder, by watching more videos, by writing more summary notes. But once he answered me like that, that was the beginning of everything shifting entirely for me. Because from that moment on, I stopped obsessing over how smart other students were. I stopped comparing my performance to theirs. And instead of that, I just started obsessing over one question. What do the top students actually do differently? Now, I want to be clear about something. See, top 1% engineering students aren't superhuman. They're not solving partial differential equations in their sleep, and they're not finishing assignments in 30 minutes with a little smirk on their face. What they're actually doing though is they're approaching learning as a craft, most importantly as a system altogether. You see, average students treat learning like a to-do list. They go to lectures, they copy what's on the slides, they do the tutorial questions, maybe cram a little bit before the test, and then they hope for the best. But the top students, top students approach learning like engineers approach systems design. They are constantly asking the following questions. How does this topic connect to what I already know? Where does this concept break down? What is the underlying principle that's actually driving this formula? You see, they're not satisfied with the surface level memorization. They're trying to build a model in their brain, something that actually explains the behavior of the system, not just what parrots the correct answer. And the most fascinating part is that this kind of learning doesn't even take more time. In fact, it often takes less time. Because once you build that model, once you understand why fluid velocity increases when a pipe narrows, right? Or why heat moves the way it does through conduction, you don't have to memorize 20 variations of a problem. You just apply that logic that you've internalized. Now I'll give you an example, right? In my second year, I used to spend hours rewatching lecture recordings because I felt like I was missing out on things. And I'd go through thermodynamics lectures again and again and again, trying to catch every step of the derivation. And still, come test day, I would freeze the moment the numbers looked slightly different than the examples that I practiced. Now compare that to one of the top students that I studied with later. He would go through the same material just like I did, only once. But he wasn't just listening, he was questioning. He was pausing to ask himself, what does this mean physically? Could I explain this to a first year student? And if the answer was no, then he wouldn't move on. He wasn't passively absorbing information. He was actively constructing the concept in his brain. Not just the equation, but the physical story behind it. And that is the biggest separator that I've seen. Top students don't work harder. They don't rely on innate brilliance. They just learn differently. They build understanding like engineers build machines, piece by piece, function by function, with every part needing to make sense before they move on. So if you've ever felt behind or felt like you've been working harder than others and still not getting the results that you want, you're not broken. You just haven't learned how to build your learning system yet. And that is what we'll build in the next section. Alright, so now that we've established that the top students aren't super geniuses, but rather system builders, let's talk about the actual system itself. And at the center of it is what I call the engineering mental model. This isn't some abstract motivational idea. I mean it literally. Like, top students build an internal working model of whatever topic that they're trying to learn. You know, like a simulation running in their head. Not with exact numbers or messy formulas, but a conceptual framework that they can troubleshoot, they can predict, they can expand on. Now let me show you what that actually looks like. Imagine you're learning about a cantilever beam. You know, like a beam that's fixed on one end and has a load on the other. Now the average students might memorize the formulas, like maximum bending moment is equal to load times length. Deflection formulas for different types of loads, stress distributions along the length. They'll make flashcards, rewatch lectures, maybe solve a few practice problems, but it all stays very surface level. They know what numbers to plug into the equations, but they don't really understand why the beam behaves the way it does. Now the top students, they approach it completely differently. They step back and ask, what is actually happening physically inside this beam? And they come to the answer that one side of the beam is actually under compression and the other under tension. The fixed end resists the rotation caused by the load. The farther out the load is applied, the bigger the bending moment at the fixed point. And they start building a mental movie, picturing how the material fibers stretch and compress, where the maximum stresses are, why deflection increases with distance. So when they see the formulas, they're not just blindly applying them, they're seeing the formulas as translations of the physical behavior that they already understand. And the key is this: they didn't build that mental model by grinding 200 bending moments problems all night. They built it by actively asking, what does this term actually mean? What's physically happening here? Why does moving the load farther increase the moments linearly? And this is a massive shift, because once you have that mental model, you don't need to memorize like 50 different bending cases, right? You can just intuitively predict what would happen if, for example, the beam were twice as long, or the load would move halfway back, or the material would switch from steel to aluminum. And you can simulate those variations mentally in your head because you have that internal map. And I know that that might sound like something only experienced engineers can do, but trust me, the top 1% students are doing it in their second year of university. They're not just solving for the right answer, they're actually understanding the system itself. Now here's the best part. Building this kind of mental model isn't complicated, but it does require a shift in how you approach learning. See, most students show up to lectures like an empty bucket, waiting to be filled. But top students, they show up like an engineer at a troubleshooting session, already having a draft understanding, looking to test and refine it. Does this explanation match what I thought? If not, where does my model need an update? It's like live tuning a simulation inside your mind while the professor talks. That's why priming, which is quickly reviewing before class, is so powerful. Not because you magically master everything beforehand, but because you walk into class with a hypothesis to test. You're not just absorbing information, you're actively calibrating your mental model. That's what makes the top students so fast. So if you ever feel lost in a topic, don't just rewatch the lectures hoping that it will magically stick. Ask yourself instead, where is the missing connection? Can I sketch out what's happening physically, even roughly? And the answer is no, and that's your work. Not fancier notes, not rereading the slides again, but rather building the missing bridge inside your mind. Now let's address something that haunts every engineering student at some point. You finally understand the concept, you walk out of the lecture thinking, yes, that actually made sense this time. You do a few tutorial questions, you feel like you're getting the hang of it. And then test day hits. Suddenly the numbers are very weird. The diagram is flipped and everything that made sense just melts out of your brain. And you're sitting there thinking, I literally studied for this. Why can't I remember how to do it now? That right there is the difference between exposure and retention. And this is where most engineering students unknowingly sabotage themselves. Because here's the truth. Just doing a bunch of practice questions doesn't guarantee the knowledge is going to stick, especially under pressure. See, what most engineering students do is that they practice passively, they follow solutions, they write down the correct steps, and then the moment that they get it right once, they move on. But that kind of learning is shallow. It doesn't challenge your brain to retrieve anything. It just reinforces recognition, not understanding. And top students take a completely different approach. They don't just do questions, they train their memory like engineers train systems. By feeding it inputs, analyzing the response, and then tweaking the mechanism until it's reliable. Now let me show you what that actually looks like. Let's say you're studying for a mechanics exam and you're working through shear and moment diagrams. Most students will solve like 5 examples in a row, maybe check the back of the textbook, get a few right, a few wrong, and then they keep grinding. But the top 1%, they'll solve one example and then they'll ask themselves, okay, could I recreate this problem from scratch without looking? Could I explain to someone else why this moment is 0 at this particular boundary? What would happen if I change the load from 1 point force to a disturbed load? You see, they're not just solving problems. They're activating the retrieval pathway again and again in their brain. Because retrieval, not repetition, is how long-term memory is actually built. This is known one of the most powerful learning methods in cognitive science. But here's where it gets even better. When you combine active recall with spaced repetition, you create a memory system that's nearly bulletproof. So what is spaced repetition? Well, spaced repetition just means reviewing the material again at gradually increasing intervals. Not the night before, not 3 hours before the exam, but 1 day later, 3 days later, a week later, 2 weeks later, right? Each time you try to recall information from scratch. Not rereading, not reviewing notes, but literally closing the book and saying, all right, let me explain Newton's second law in rotational form and how it connects to angular momentum. You see, if you can't explain this, perfect. Now you know exactly what to review. If you can explain it, you reinforce the memory even more deeply. And over time, the magic happens. Concepts that once felt like puzzles that you had to solve every time become intuitive. You start seeing patterns without trying. You enter a test and it feels less like solving a riddle and more like translating what you already know into a new language. That's when you know that you've reached what I call engineering fluency. And no, this doesn't take 12 hours a day. It just takes consistency and deliberate strategy. Now, a quick note here, just because this trips people up, right? Just because spaced repetition and active recall are simple doesn't really mean that they're easy, because they feel uncomfortable. They force you to fail on purpose, to try to recall something when your brain isn't fully ready. But that's exactly the point. If it feels too easy, then you're not really training your brain, right? You're just reviewing. And think of it like lifting weights, right? You don't get stronger by just looking at the dumbbells. You get stronger by putting tension on your muscles, right? By doing repetitions that hurt a little bit. And studying is no different. Repetitions for your brain. So if you're somebody who spends like 10 hours doing practice problems but still forgets everything by exam week, ask yourself, how many of those hours were spent actively recalling from memory, under time pressure, without notes? Because that's where the 1% live. In that uncomfortable, awkward zone where your brain is forced to work. And if you can get used to that discomfort, if you can build the habit of failing forward, right? Recalling before you feel ready, testing before you feel confident, that's when your brain starts to change. Not just how you remember, but how you think altogether. Alright, so now you know how top students build real understanding. Not by brute force, but by designing better learning systems. You know how they retain and apply what they learn, not by memorizing everything, but by training their brain like a muscle. But here's the part that nobody ever talks about. Because let's be real, engineering isn't just intellectually demanding. It is logistically brutal. You're juggling like 4, 5, 6 sometimes courses at once, right? Each one comes with lectures, tutorials, pre-labs, midterms, assignments, projects, exams, all of it stacked up, often at the same time. So even if you know how to study effectively, there's still the question of how do you manage it all without constantly burning out or dropping the ball? And this is where we separate the good from the elite. Because what the top 1% students understand on a fundamental level is that engineering school isn't just a test of knowledge. It's a test of systems management. So let's talk about how they run their semester like a tight operation. How they plan, how they focus, and how they stay composed when everyone else is panicking. Number one is that they don't use to-do lists. They use time blocks. First off, top students don't wake up every day with a list of vague tasks like, study for fluids or review control systems. They know that's a recipe for anxiety and procrastination. Because when everything is a priority, nothing is. Instead, they pre-allocate their time using time blocks. Usually on Sunday evenings, they'll sit down and map out their entire week. Not just deadlines, but deliberate work blocks. Like 2 hours here for problem sets, 1 hour there for lab prep, 30 minutes for Friday mornings to review the toughest concept for the week. And the difference? They're not just reacting to stress, they're anticipating. They're making small deposits of effort before things get urgent. And this is key because in engineering, you don't fall behind overnight. You fall behind one unchecked concept at a time. One unreviewed lecture at a time, one skipped problem at a time. And by the time you realize it, it's already midterms and you're staring at a 72-page study guide full of question marks. Top students avoid that spiral by design. Their calendar is not a constraint, it's a safety net. Number two is that they don't study harder when overwhelmed. They simplify the process. When the average student gets overwhelmed, they double down. They pull all-nighters, they skip meals, they cancel plans, and then they still fall behind. Why? Because their mind is overloaded. Top students do something counterintuitive. They slow down. Instead of doing more, they ask, what is the one thing that I need to understand today that makes the rest of this easier? If they're confused by heat transfer, for example, they don't try to memorize all of the correlations at once. They'll spend one focused hour just to understand the physics behind, for example, convection. And then once that's solid, they'll build outward, layer by layer. And this isn't slacking. This is called strategic simplification. They reduce complexity so that their brain can move deeper and not faster. And number 3 is that they create repeatable routines, not motivation-based bursts. Now here's the cold truth, right? Most students are addicted to motivation. They wait to feel ready to study. They wait for the pressure to kick in. They ride a wave of panic-fueled adrenaline until it crashes. But the top students, they don't rely on motivation. They rely on routines. They have a default flow for every week of the semester. Monday is tutorial review. Tuesday is concept mapping. Wednesday is group study. Thursday, flashcard review. Friday, weekly recap. This isn't rigid or robotic. It's freeing because it removes decision fatigue. You always want to know what today is for. No guesswork, no mental friction. This is what makes consistency feel very easy for the top 1%. It's not that they're more disciplined, it's just that they've designed a system where discipline isn't even required all the time. And then number 4 is the silent habits, right? Weekly reflection. Now I want to share a habit that's almost invisible, but unbelievably powerful. It's the thing that I've noticed in every top performing engineering students I've ever studied with, right? And no one talks about it at all. They reflect weekly, quietly, consistently, usually on a Sunday evening, right? Or after they finish their last class of the week. They take like 10 to 15 minutes, no distractions, and they just ask themselves, what did I actually understand this week? What still feels fuzzy or disconnected? Where did I waste my time or get stuck, and why? What is my plan for doing better next week? They might jot it down in like a notebook. They might just talk it out in their head while taking a walk. But the point is that they check in with themselves. Not academically, but mentally, systematically, strategically. Because success in engineering isn't about perfection. It's about continuous calibration. Tiny tweaks, iterations, course corrections, right? You don't need to be the smartest person. You just need to be the most self-aware. So let me leave you with this. If you're struggling in engineering or just stuck in that cycle of working hard but not seeing results, then just please hear this out. You're not broken. You're not smart enough. You're just early in the process of learning how to learn like an engineer. Because this degree isn't just testing your knowledge. It's testing your ability to build systems inside your head, inside your calendar, inside your habits. And once you shift from reacting to results to proactively building your mental models, your review systems, your routines, everything changes. That is how you become the top 1%. Not with more hours, but with better architecture. And you're capable of that. All of it. Starting now. Starting today. If you found this video helpful, drop a like button and subscribe if you haven't, and I'll see you guys in the next one. Peace.